All right, here we are, day 23 of 100 Days of Code. Hopefully coming back to succeed at implementing Dijkstra's shortest path, Dijkstra's? Not sure, on an adjacency list. I failed at that pretty hard yesterday. I was copy coding for the most part and trying to get an implementation with an adjacency list and then a min heap keeping up with distances. And the min heap was causing me all kinds of trouble and made it much more difficult to debug. So I think what I'm going to do today is mimic my adjacency matrix implementation of sorry, got distracted. Mimic my adjacency matrix implementation, and then come up with my own way to add them to, or parse the adjacency list to get the distances. I know I'm going to have to do some, it's not going to be easy, but hopefully I'll get more out of that than debugging this other implementation that's not my own. Yeah, so that's kind of the goal for today. So no heap. I guess this stuff's already been committed, so there's no need to keep it. Feels kind of weird just ripping it out though. All right. I already have the adjacency list. I already have Dijkstra's. I can pull up the code. Can I? Yeah. I should at least have the Geeks for Geeks page up because it has the I'll think of the word. The answers to the test. That's it. Graphs. And Dijkstra's is in here somewhere. I've been saying Dijkstra's. I heard someone on YouTube calling it Dijkstra's. I'm just going to roll with that. It's the first time I've heard someone say it. Correct me if I'm wrong. Here we go. Cool. So this is what I was trying to implement, and I couldn't get it working for some reason. That's totally okay. I did learn a good bit by doing this. Yeah, but those are my answers. So that's why I wanted to have this pulled up. That way when I test it, I can make sure that it's working off the same data. Okay. So I need a min distance. And we're just going to put this right under depth first search. I know that's not going to work right off the bat. That's okay though. And we can do float infinity. Okay. Cool. So that should not work at all because the way it's referencing the matrix just doesn't exist. So that's fine. Distances and shortest path. Shortest path. Man, I might have to bring up this implementation too to make sure I remember everything correctly. Okay, that's okay. Shortest path set will be true if vertex I is included in shortest path tree, or shortest distance from source to I is finalized. Okay. Count and graph.length. There is no graph. We're just using an array. So pretty sure we can just use array here and array here. Same with this. Gonna have to fiddle with add edge. Yep, that's fine. Int max is fine. That's fine. Yep, I'm gonna try and still keep this the same. Right. Oh, this is where my brain gets muddy. We'll see though. We'll see. All right, so that's still using graph notation. That's still using graph notation. That's still using graph notation. So I need to be able to access the array.length. I've still got the old add edge down here. It's adding them to the front of the array for some reason. Not super sure why. And I really want to make that an object. So I think I'm going to make an def add edge object. And this will be source, dest and dest, and was, oh, wait. If I could spell, that'd be helpful, I think. Guess not, as long as I get it right and get it the same. So that will be at array. Source dot push oh right, because this is an array I have to do some checks. Test wait that's equals it less and then do the same for destination. Okay. Seemed to think it was a big deal to push it the other way as well. So I'll just do that just for now. I have a feeling it's going to make things a little bit muddy. That's all right. Let's be adjacency list.new, and all of these will have an object on the end. Don't like the way this is working. This is the slowest way to do this possible, I think. Okay, cool. Gotta get a really full adjacency list, so I don't want to do this yet. Okay, so I do have an attribute accessor, so I can do p graph.array and run the tests. Ruby test graph adjacency list test. Cool. Each I that's a better way to look at it. Okay. Let's compare those. Yeah, I guess you can't see those. That's a little bit better. Not great, but better. All right, so we add at 0, we get 1 and 4. 0 and 4. Okay, cool. Looks like it's working. That's good. Let's put that over here. Oh, so I need graph.closest where destination is equal to v. And then I need to return the weight. Okay, so yeah. So that becomes at array closest. Where's pseudocode, mind you? We're at closest where dest is equal to v. Return weight. So I need to make a method called getWeight. Get weight. Def. And this already has access to the array, but I will need a source and a destination. So that would be at array, not dot, but source dot each. So we weight equals, I don't, at int max. Weight equals I weight. Source each right, so if I destination equals dest, and then return weight. It's gonna make this check weird, but I think that's fine. Man, I kind of hate to make this nil. No, I'll just add in another check if it needs it. That'll be the better way, I think. Oh no, because this covers it. This covers it here if it's less than distance v. Okay, cool. So now I have a get weight that I can replace this. So get weight. Same here. Get weight. Distances v is fine, and this will also be get weight. And my magical hope is that this will just work. Here's to hoping. I actually have to call Dijkstra's on it, so that's a thing. That's a thing. It's in the test. So, 0, 4, 12, 19, 21, 11, 9, 8, 14. Guess what? 0, 4, 12, 19, 21, 11, 9, 8, 14. Booyah! Ugh. Maldacross, Vizgar, if you guys are out here in any way, shape, or form, or happen to see this, thank you for that suggestion and steering me away from the min heap. I believe it was Maldacross. Thank you so much. Yeah, this was way more simple, and yeah, I don't necessarily need to implement this with a min heap. Cool. So I got it working for an adjacency list. And that was pretty dang straightforward. $20 in. Took me 2 hours of debugging the other code yesterday. It's fine though. It's fine. These things happen. Man. Yeah, I'm gonna take a quick break and I'll be right back. Oh my goodness. Gotta go scream into a pillow or something. All right, I got it out. I'm better now. Oh, jeez. Okay, great. How wonderful. Yeah. Cool. Well, I got that working. I did not expect to. So I guess I'll set up and make sure these tests work. And I'm just deleting all this. That's out of here. I don't even care. Cool. Yeah, let me actually set up these tests. Equal. Oh, I think it just printed the array out. Yeah, so that's fine. Make sure I didn't break any other things. Oops. There we go. And run this test. Oh, I can remove some prints. Where is that printing from? Oh. Did I forget to save something? Shouldn't have printed this again. Weird. Guess I'll search for that. Oh, yeah. I missed it because it was nested. There we go. Cool. So that works. And that is an appropriate test now. Now I can go over here and it's the same test. Can put that in here. Test Dijkstra is what I want. Okay, and I want it for an adjacency matrix. Oh, still printing it out, but test. Yeah, it's fine. It's fine. Cool. Okay, that's pretty awesome. Yeah, so that works. Wow, that was way more simple than I was expecting. Oh yeah, I can make this float infinity. Yep, still works. Awesome. Git add. Yeah, I'll just do it all. Dijkstra's. Whoo. Oh, that feels so good. Oh, yes, that's awesome. Oh no. Did I close Chrome? Poop. Well, if you're in chat, I haven't seen it. I doubt. No, I mean, it's probably fine. Oh gosh, I closed everything. Ugh. There we go. Perfect. Now I'm back. Weird. I don't know what I did. Oh, I guess Chrome updated. Closed. I don't know what happened. Well, all right. Well, geez, what do I want to do now? Oh, did I lose? I lost those pages too. Poop. I almost don't want to do anything else on graphs. Yeah, I'm just gonna poke around, see what there is in graphs. If I don't find anything that I want to do, maybe I'll go and plunk around on CodinGame. Yeah, I'm kind of spent on this. Yeah, why not? Why not? Let's just go do it. Make sure access to passwords. Oh my gosh. Did I not save it again? Oh, not that one. Ooh, well, I'm logged in. Okay, so someone suggested that this is a cool place to use Dijkstra's. I've already got the code for Dijkstra, so I can just modify it and see if I can get it to work in here. Yep. Solve it. All right. Let me just read through this and make sure I understand it. Right, let me edit the stream info. It's not quite. Yeah, that'll be fine. Okay. So for this particular puzzle, they definitely lay on the framing pit thick. Apparently I'm Kirk and I have a jetpack and I have to go to the control room and what does it have to do? I have to activate something. Activate the tracker beam and then get back to my starting position. But I can't touch any walls or I die. And if I run out of jetpack fuel, I die. And there's a timer. So I have to make it in a certain amount of turns. It's an ASCII format, so it's fine. Text is easy to process. Looks like there are actual traps as well. Oh no, the letter T represents your starting position. Okay. C represents the control room. Question mark represents a cell that I have not yet scanned. Okay. Cool. Okay, so that's normal. Okay, RC, number of rows and columns in the maze. Okay, awesome. A is the number of rounds between the time the alarm countdown is activated and the alarm goes off. Okay. Maybe won't need that. then it's probably Kirk row, Kirk column. Okay. Okay. 0, 0 is top left. Next R lines, C characters. It's one row. Okay. There's a single T character and a single C character within the maze. That's good. Oh, they've got some framing. Nice. Okay. Initialized output starts at 0, 1, 2, 3, 6. Only 25 cells are visible. Cart moves to the right. Yep. Okay, cool. I like this. So I'm not gonna try and implement Dijkstra's for this yet. I don't even know how I'm gonna do that to start with. I'm just gonna play around with it and see how movement works, see how the game works. Yeah, so this seems fine. Let's play it and watch it play. Cool. So let's print each row, see what that looks like. Okay. Just left 1200. Oh, right, because yeah, I need to standard dot puts row. Oh, that's super cool. Okay, so I need to make a matrix, and then let's put that here, and let's matrix dot push row. Nice. like that better. Okay. Cool. So I'm getting information. Oh yeah, there's only one way to move. Yeah, let's see what this test case looks like. Yeah, he just fails automatically. Okay, cool. Okay. Oh, so we get rows and columns in the timer. Yeah, that's fine. Def, find, control. Oops, didn't really want to do that. It's going to take in a matrix, and it will spit out XY coordinates. I'll call those R and C, row and column. Character and oh right, this isn't character yet. This is row and R. That's how I do it. And then row dot each with index do call. So we can call this character and C. If character equals C. It is a capital C, right? Sure. I want to break. And all right. It's -1 and C equals minus. You know what? Gotta call them X and Y. I don't have a better way. X equals R and Y equals column. I think that's backwards. R. So basically, I'm creating this to find the control. Oh, I should probably print that out and see if it actually works. C. At C. At C. Yeah, so let's see if we can find the control room. Ooh, undefined method empty. Ah, right. Let's try again. I never put it out. Let's try again. Nothing. Gotta get my logic right. And 13. Was it not right? Each line. What is row? Is row a string? Array. Let's try matrix 0 dot class. String. Okay. Did I pass it in? I did pass it in. Okay. Did I mean each line? Why does each with index not work? Oh, can't do it for this. Dot. Should probably read. There we go. It's always question marks, huh? Maybe it's not fast enough. So it never finds this? Thought that was the right way to do it. This is fun, just like getting this to like move and print stuff out. All right, I know we have T. Okay, we never find C. Okay, maybe it's the wrong way to go about it. wonder if I could do something like for row in Kirk row -1 dot dot Kirk row +1. Why does it never see the C? I know it's there. Let's just make sure that keeps getting called. Yeah, nothing. Let's matrix. Bam. Okay. Mistypes. So many mistypes. Oh, is it just printing out the... yeah, it's just printing out the first one because I'm silly. And I mistyped. There we go. Hey, and it found it. Nice. Cool. So that's a little faster. Let's see if it actually gets assigned. No, I know it's not getting assigned because I'm not doing anything. If matrix row, I include C. X, no, Y. Y will equal row. You return Y there. Let's make sure that gets passed through. Yep, awesome. And it keeps checking for it, so that's fine. Now I just need to make sure that I include the appropriate X. So that means X will equal... matrix row dot find C. I'm gonna look that up. Ruby find index in string. Okay, cool. This is exactly the API I thought it was, just not the right word. Index. Let's try that again. 12, 6. Yep. Okay, cool. And now I want direction to equal left if KC KR KC equals at C. There we go. And that should be good enough. Nope. Okay. All right, what happened? Does this not update fast enough? What's happening here? Oh, kind of backwards. Nice. I think that's a bad way to do that, but it's fine. Ah. Gosh, how do I always set it to that for every loop? I don't think this is gonna work. I'll try it, but I don't think it'll do anything. I think we'll just have the same thing. Nope, it worked. Yep, you see the labyrinth. Perfect. What's up, Maldacross? Yeah, I'm just dinking around with it right now. I'm not super sure how to get Dijkstra's implemented with it. But I did get it working on an adjacency list. Yeah, it was much easier with your suggestion. I just scrapped all that code that I worked with yesterday. Oh yeah, and I'll show you. For what it's worth. So you saw the mess that I was working with yesterday. This is my implementation for an adjacency matrix. And effectively for an adjacency list, all I did was copy that over, and made this little get weight method that just, access the objects in the array. Yeah, it wasn't exactly the implementation that you mentioned, but it's much easier than the min heap. Yeah, maybe I'll revisit the min heap at some point, but I was just happy to get it working and functioning and have some understanding of it. Oh yeah, and then I had to add this little object thing. Yeah, so now it's just like playing around with the labyrinth. Okay, so it gets more complex. Uses 4 directions. Yeah, it was cool. Thank you. Thank you. Yeah, and I've just been like playing around with this and trying to figure out some way to massage this code into a usable form here. Yeah, so I'm just playing around for now. I haven't even tried implementing it. Yeah. Trickiest part of the labyrinth is to figure out what the graph representation of the grid would look like. Yeah, that makes sense. That makes sense. Yeah, because even for the first one, right, like printing out the whole graph here. Oh, can I make this bigger? I guess not. Let me zoom in. Yeah, it looks awkward zoomed in. But yeah, I see what you're talking about. Like, figuring out how to set weights. Do I even need to set weights? I mean, maybe not. Because it's either on or off. Right? I can pass through it or I can't. I guess every loop you'd want to add the new edges. I think adjacency list makes sense. Just because you don't really have to keep up with weights, I don't see why you would want to. Man, maybe I will try start on this and see if I can get it to work. Definitely gonna use that. Okay. This is probably going to be pretty verbose. It's fine. It's fine. You haven't figured out a way to make the question marks a part of the graph, so just stored them in a separate set and kind of pointed Kirk in the direction of the dots adjacent to reachable question marks, if that makes sense. Oh. So like, yeah, I think that makes sense. So you added the, like, his general direction skewed towards unknown parts of the map. Oh, I guess that makes sense because you have a time limit, or not a time limit, but your fuel runs out. Okay. Oof, this is going to be kind of verbose. Or, I mean, a lot of data each round. Yeah, the fuel is a factor, but it's like I had to always figure out the meaning of life for Kirk, because otherwise there was a else raise do something in my code. Huh. Okay. Oh, Dijkstra's doesn't work without the weights, so I have to have the weights. Ugh. Alright. Okay. I wonder if you could just set 3 weights. And have dots be 1, question marks be 2. And then... yeah, I'm not sure. Oh, but then you need to do it all in reverse? I don't know how to do that. So this will be... row dot. Oh, we don't have what? Yeah. Oh, this is confusing. I don't have fine control anymore. We got the matrix. Yeah, don't have that. Okay, I still got plenty of time. All right, I keep trying to think this. Let me just see if I can create an appropriate adjacency list. Okay. So that means yeah, this is gonna be way too much every loop. Gonna try it anyway. Okay. And now I want to add edge. All right, I need to set the weight. Equal to R comma C 2 my brain just broke. So I need to make an XY to an XY. Oh, and then I need to do everything around it? Well, that seems like way too much. Huh, so I guess when I was doing this earlier, I already had all the information in the edges. I didn't have to come up with it on my own based off of input. Representation of the grid. Yeah, I see why this is hard now. Hmm. Right, right. And that means all 8 neighbors, which is a lot. Aw, redo doesn't work. Let's try Command C. Ah, perfect. They're just... Oh, right, because you can't go in diagonals. You can't go in diagonals, right. Adding it both ways, so that's fine. And that would be for... Oh gosh, let me just type it out. R -1, or... R -1C, or... R -1C, R +1C, and then C -1. Yeah, okay. So we add 4 edges each time. Oh, and this way I can check against R, C, and A. I think you inspired me to put more of my code on GitHub. Nice, nice. Yeah, you should totally do it. Oh, I still haven't taken a good look at your bad enums yet. Thank you for reminding me. I'll get on that. Okay. Squirrel, what's going on? Damn, Ruby, huh? Where is Ruby used in the real world? Besides Metasploit? I don't even know what Metasploit is. Yeah, Ruby's used in a ton of places. The company that I work for, we use Ruby on Rails, Ruby, as the backend for our SaaS software. And places like GitLab, GitHub, Shopify. I think Shopify has the biggest Rails monolith. And I found some others. There's another e-commerce place called Shogun. Yeah, those are just a handful off the top of my head. Good question though. Good question though. Is it high? I'm not sure. It's efficient enough. Yeah. So I worked at a consultancy previously, and we had tons of arguments over Node versus Ruby and Ruby on Rails. And the argument was always that Ruby on Rails was super slow. But as I've come to learn, good enough for government work. Nice. As I've come to learn, Ruby and Ruby on Rails is more than fast enough for most things. Only once you get to a certain scale is it... I don't even think that's true. Like, it's viable way, way up in scale. Alright, I need to figure out the weights. does that work in Ruby? Just need the syntax. Case when. Okay. Camera, you silly. Or when. Oh, right. I don't even have to do that. I can just do when dot return 1. When question mark return 2. When that return. Yeah, I never want to go there. Load. Right, is that correct? I don't even have to add the return. That's great. Okay, and now to standard error dot puts at hash. That's not going to print very well. I missed many things, many things. Hey. Man, that's going to be forever long. It did not provide input in due time. Nice. Yeah. Not too surprised that that is way too slow. Oh, okay. I'm not printing it. Seems to be a little bit faster. All right, well, I have something. I'm just gonna slide. Nah, I'll leave it here. I'll leave it here. Just doing it. Just doing it. Is that the new M1 Mac? It is not. I think this is like 2019 Mac. One of my coworkers got one of the new ones and had some basically had a lot of trouble getting everything set up and running. He got it before the Docker release came out. Yeah, so he like pulled the beta of Docker and whatnot. And sounded like an adventure, to say the least. I'm going to try and hold out and see if they come out with a 16-inch one that's better and has like 32 gigs of RAM. Hopefully that'll be later this year. I'm only going to print out the distance, return the distances. They're likely going to have an Intel variant. Ooh, that'd be cool. Oh man, it'd be so awesome to have a Linux machine with a system on a chip. Get the hash in there. Ah, right. This little guy. M1 is faster, but Intel has more software options for now, so they likely don't want to hurt their customers yet. Oh, for the new MacBooks, they're going to have an Intel variant. Oh, I see. I thought you meant that Intel was going to come out with the system on a chip. Intel x86 forever. Yeah, probably. So Dijkstra. This is gonna be ridiculous. There's no way there's enough time for this to all happen. Oh. $25. Yes. Oh my gosh, am I gonna have to make the distances A grid.
Oh, that's crazy.
That's crazy. Oh my gosh, this is getting nuts. Cool. That's better. Command C. There we go. So now distance is a hash. I don't know what that means. Ugh, this is getting so gross. All right, now let's see if it's doing anything at all besides an infinite loop. This puzzle is weird. It's about exploring the entire map and then finding the shortest path back. Yeah, I think that sounds about right. Oh, I wasn't thinking of it that way. But yeah, you're right. So I guess I only have to explore the map and then find the shortest path back. Well, thank you for that. I guess I don't have to do Dijkstra's every single time. I only have to do it once. Which is okay. This progress doesn't change this progress at all. Haven't done too many hard puzzles because the pathfinding isn't fun to me. Yeah, I'm really bad at it. I only learned about Dijkstra's shortest path in the past few days, and it's the first ever time I've looked at it. And I have no idea how to implement it for this puzzle. I'm just kind of having a go at it and seeing what I can figure out. So I know exactly how you feel. Oh, right, it timed out. I was going to see what we were doing. Puts. And I just want to see something like distances. Oh my gosh. But it's totally fun. Yeah, I am enjoying it. I am enjoying it. Oh my gosh. All right, I guess if I'm thinking about it, Squirrel, I think you're right. You can just openly explore the map, as long as we don't get caught in a loop, until we find the control room. As soon as we found the control room, that's when we actually need the shortest path, and then we can shrink the matrix that we're creating down to the coordinates of where the start is and where the control room is. Worst case scenario, that will be full grid. Oh, I guess there are some gotchas, like if they end up being right next to each other, but if you have to go around. We'll see. We'll see. Camera. I really hope my camera has said no memory card for a long time. Okay. About 10 minutes. Nice. Nice. Alright, does that time out? No, that's fine. That has a ton of edges. So I guess if we're going row by character, it only needs to add the ones going in a positive direction. Dijkstra. What you're curious about is if it finds the control room, but you haven't explored the entire map. What do you mean? If your algorithm is searching and finds the control room, it might have the wrong shortest path back. Oh, I see. Oh, so if it takes a long time to find it? Huh. Alright. Cool. Okay. Oh yeah, I can do a range. So I want to do Kirk grows -1 ... Kirk grows +1. Did I not do that right? Oh. Still doesn't complete in time. Zero, 1, 2. So that means the row is not going to be the one that I want. Oh, no, it is. So it'll be 0. Oh, okay, so I need to add it back here. Okay, see. This feels icky. Cool. Starting to run out of time. Okay. Cool, so my Dijkstra's implementation is taking a long time. Dijkstra's. I can at least get a decent view of what's happening. So let's not call this yet. Let's not call that yet. How do I compare arrays? Oh, silly camera. Got it that time. Ugh. Oh, I can do this. That's nice. Go ahead and shrink all of the Dijkstra stuff. Oh, next is a keyword. Okay, before I have to get out of here, just want to make it do something. Haha, nice. Thanks there, Muumi Jumala. Seven. So that's wrong. All right. My hope was to at least get it to move around in some intelligent form or fashion. But unfortunately, it's time for me to hop off of here. So, thanks for everybody's input and hanging out for a little while. I'm going to wrap up by making some commits. Let's see, status. Oh yeah, that doesn't need to be there. It's fine. Yeah. Cool. So this is the ending of day 23 of 100 days of code. And I got that working. Which was the real goal of today, is to get Dijkstras? I don't know. If anybody knows, that'd be awesome. Yeah, I guess I need to study up some more on Dijkstra's shortest path. Maybe I'll play with this some more. The labyrinth tomorrow. Not sure. Seems like I'm missing a few key concepts on how to get that working exactly. Oh yeah, that's fine. All right, and day 23. Read meme. Push. Oh, that's nice. Awesome. Yep. That's it for me. Thank you very much for being here and joining in. And I'll see you all later.